Hi all, in this video I am going to explain one problem in diode that is coming under the subject power electronics. Problem number 1. In the diode and LC network shown in figure, the capacitor is initially charged to voltage V0 with upper plate positive. Switch S is closed at t is equal to 0. Derive the expressions for current through and voltage across C, that is capacitor and diode. In the circuit, it consists of diode, inductor and capacitor. I am going to derive the equation for voltage across capacitor and diode. See, when switch S is closed, at that time, diode D, that is in the forward bias condition, so it starts conducting, the switch is closed. Here this switch is closed and this is act as a closed switch. Now I am going to write the equation using KVL. What is the equation? L into di by dt, that is the voltage across the inductor, plus 1 by C into integral I dt equal to Vs. Here I am going to consider the initial conditions also. Then apply Laplace transform. So what is the Laplace transform? We consider the initial condition L into S into I of S minus I of 0 plus 1 by C into I of S divided by S minus of minus, both the voltages are opposing with each other. So Q0 divided by S, that is equal to Vs divided by S. Next, I am going to apply the values Si of S minus, what is the initial value of current through an inductor? 0 plus 1 by C I of S divided by S plus, what is the initial value? The capacitor initial voltage is V0. So C V0 divided by S, because Q is equal to C into V. That is equal to Vs divided by S. Consider the initial conditions I of 0 equal to 0 and the initial voltage in the capacitor is V0. So Q0 equal to C into V0. Have to rewrite the same equation A, and substitute these values in the equation A. The new equation is L S into I of S minus 0 plus 1 by C into I of S divided by S plus C V0 divided by S, that is equal to Vs by S. Next I have to expand this equation Ls into I of S plus 1 by Cs into I of S plus Cc get cancelled, V0 by S equal to Vs by S. Next take I of S outside, so Ls plus 1 by Cs, that is equal to Vs minus V0 by S. And next write I of S into, you have to take LCM, S square LC plus 1 by CS equal to PS minus V0 divided by S. S get cancelled. So I of S is equal to Vs C into Vs minus V0 divided by S square LC plus 1. And next, how to simplify this? C into Vs minus V0, take LC outside. So inside S square plus 1 by LC. CC get cancelled. So what is the next step? Next step is Vs minus V0 by L into 1 divided by S square plus 1 by LC. What is 1 by root LC? That is equal to angular frequency omega naught, that is otherwise known as resonant frequency, 1 by root LC. So, this is I of S. Ps minus V0 by L. Then have to substitute S square plus omega naught square. Next I am going to find out I of t. For finding out I of t, I have to find out the inverse Laplace transformation here. The first term is a constant. In the second term is almost look like sin omega t. What is sin omega t? Omega by S square plus omega square. But which term is missing? The numerator omega is missing. So you have to multiply and divide the equation by omega naught. Vs minus V0 by L into omega naught. Multiply and divide by omega naught. So L into omega naught here. Here S square plus omega naught square. How to write this? Vs minus V0. What is omega naught? L into square root of 1 by LC into inverse, take inverse Laplace into what is omega by S square plus omega square, that is sin omega t. In a similar manner, this is sin omega naught t. Yes, I have to rewrite this. L get cancelled and root of L. So what is the answer? Vs minus V0 into square root of C by L. Here L by C in the denominator. If we take the inverse, we get root of C by L into sin omega naught t. This is the current I of t. After finding out the current I of t, I am going to find out voltage across the capacitor, that is Vc of t. What is Vc of t? Vc of t, using the current, we are having one voltage. Already one voltage is in there in the capacitor. So summation of both, we get the total voltage in the capacitor. Vc of t equal to 1 by C integral I of t into dt plus already existing initial voltage V0. Vc of t is 1 by C into square root of C by L into Vs minus V0. These are constant. Then inside, put the integration, write the limits, sin omega t into dt plus V0. CC get cancelled. So 1 by square root of LC Vs minus V0. Apply the integration, that is cos omega naught t divided by omega naught 0 to t plus V0. 1 by root LC is otherwise known as omega naught into Vs minus V0 into minus of, apply the upper limit cos omega naught t, lower limit cos 0, that is 1 plus V0 divided by omega naught. Both are get cancelled. Then multiply minus with this term. So Vs minus V0 into 1 minus cos omega naught t plus V0. So this equation is the equation for the capacitance. And in this equation, I am going to find out the value when omega naught t equal to 0 and omega naught t equal to pi by 2, and when omega naught t equal to pi. So when omega naught of naught t equal to 0, Vc of t equal to Vs minus V0 into, this is 0 no, so cos 0 1, 1 minus 1 0 plus V0. So V0 get cancelled, but Vs. And next substitute pi by 2. Oh sorry, this term totally cancels, so V0, the first is V0. The next substitute pi by 2 here. So omega naught t pi by 2 is cos pi by 2 is 0. So Vc of t is Vs minus V0 plus V0, that is equal to Vs. Third case, Vc of t equal to, apply omega naught t equal to pi. Cos pi equal to minus 1. So 1 minus of minus 1 plus 1. 2 into Vs minus V0 plus V0. So after simplification, after simplify the equation, we get 2 Vs minus V0. Minus 2 V0 plus V0. 2 Vs minus V0. Next I am going to find out the voltage across diode Vd. So when we apply the voltage Vs, at that time switch is also closed position, diode is conducting, and at the steady state this is also short circuited. Now I am going to write the equation Vd. So negative to positive, apply the KVL. Negative to positive, voltage rise Vs. Then positive to negative, drop in voltage Vd. Again VL positive negative, voltage drop. Vc also positive to negative, voltage drop equal to 0. So from this I am going to find out Vd. What is Vd? Vs minus VL minus Vc. Here put Vs. What about VL? VL is 0. VL means the voltage across the inductor at steady state, that is equal to 0. Minus Vc is what? Vc is 2 Vs minus V0. So Vs minus 2 Vs plus V0, that is minus Vs plus V0, that is the equation for diode. That's all. These are the voltage equations for diode as well as capacitor. Next I am going to explain how to draw the waveform for current, capacitor voltage and diode voltage. See, this is the waveform for current Vc, that is capacitor voltage, Vd is the diode voltage. So first see here, I of t, what is the equation given? The given equation is I of t equal to Vs minus V0 square root of C by L sin omega naught t. So first of all, I am going to apply omega naught t equal to 0. So what about I of t? Sin 0 is 0. So entire term is 0. That is 0. Then omega naught t equal to pi by 2. So pi by 2 means the maximum value. Sin 90 is the maximum value. So that is Vs minus V0 square root of C by L. And again pi. Put omega naught equal to pi, again we get 0 value. So this is the one cycle. The first is completed. This is I of t. And next I am going to find out Vc. So Vc means the first case, Vc of t already I have explained. Vc of t is V0 when omega naught t equal to 0. I have to mark the value. Then omega naught equal to pi by 2, the value is Vs. Okay, I will get the value Vs. Omega naught t equal to pi, I get the value 2 Vs minus V0. This is the voltage equation for the capacitor. Okay, at the end of the end of the cycle, 2 Vs minus V0, this final voltage across the capacitor. And what about the final voltage across the diode? Diode, first it is conducting, no? So there is no voltage drop across the diode, that is 0. And afterwards, the diode stops conducting. In this point, there is no current flow, so diode stops conducting. And what about the voltage now? That is minus Vs plus V0. Okay, this is the point, the final voltage across the diode. Thank you. Have a nice day.